Hello, welcome to Econometrics Melody. In this video, we will discuss about the analysis of variance. We are going to distribute the variation in a dependent variable among the fitted values of y as well as the residual term. And we know that M0, this is our deviation from mean maker matrix. The sum of the error term, this is equal to 0 in OLS regression. And as the sum of the error is equal to 0, the mean is also equal to 0. Therefore, when we calculated the deviation from the mean of the residual term, it is simply equal to the residual term summation of x. When x is an individual variable, then in that case the total of x is equal to I transpose x, or we write it as x transpose I. They are one and the same thing, and the total of x can also be attained by multiplying the number of observations by the mean. And as the sum of the error term in OLS regression, this is equal to 0. That is why the total of y, the dependent variable, should be equal to the total of the predicted values or the total of the fitted values, and therefore the mean of y is also equal to the mean of the fitted values. These are the helpful concepts for today's video. So let us take the deviation from mean, and this is equal to the error term itself. Now as x and e, they are orthogonal in the independent variable and the residual term, they are orthogonal. It forms a right angle triangle. So let us take the square of it. So we are trying to take the sum of the square of the deviation from the mean. H square, this is equal to p square plus p square. A b transpose is b transpose a transpose. Also the deviation from mean maker matrix, it is idempotent. Therefore, this is equal to this relationship. It gives the distribution of the variance of dependent variable y. This is represented as the sum of the square of the total variance. This is represented as sum of the square of the variance explained by the regression, that is the independent variable, and this is the unexplained variance. So the degrees of freedom associated with the dependent variable is n-1, and we have to estimate k parameters. Therefore, the degrees of freedom is k-1, and the sum of the square of the residual, it has n-k degrees of freedom. So in general term, this y transpose m0y, this is the sum of square of mean deviation of y, and this is equal to the sum of the variance explained by our regression, that is the independent variable, plus the unexplained variance. So the total variation of the dependent variable, so some portion of it is explained by our independent variable, while some portion remains unexplained. Now let us explain y transpose m0y. This should be actually equal to y transpose y minus n y bar square. Multiply by y, and let us operate it. This is equal to y transpose y minus y transpose I transpose y divided by I transpose I. This is further equal to, and as we have already seen, I transpose y, as y is a vector, this should be equal to y transpose I, and this should be equal to the total of y is given by the number of observations multiplied by its mean. So we have n y bar for y transpose I, and for I transpose y also we have n y bar divided by I transpose I is n, and this is equal to y transpose y minus, let us cancel one, and therefore we are left with this relationship. Similarly, we have beta transpose x transpose m0 xp. This is sum of the square of the variance in y explained by our independent variable, and this can be written as y cap transpose m0 y cap, where our y cap, this is equal to x beta cap, that is the fitted value. As we know that sum of the y is equal to the sum of the fitted values, as well as their mean is also equal, because we have the sum of the error term is 0. Therefore, the total of y should be equal to the total of the fitted value, as well as the mean of both dependent variable and the fitted value should be equal. And if we learn from our expression 1, this should be equal to, this is again equal to y cap bar y cap minus, and we know that the mean of the fitted value is equal to the mean of the dependent variable itself. We know that E transpose M0E, this is simply equal to E transpose E. So this is the total variation in Y, the variation explained by our regression, that is the independent variables, and this is unexplained variation. Now in OLS regression, we can write this term in different forms, and this is going to be useful in instrumental variable age well. So let us try to expand this term and let us see in how many different ways can we write it. Now we have x y is equal to xb plus e, and we know that x and e, they are orthogonal. And this can also be written as y is equal to y cap plus e, therefore, and let us substitute y cap transpose, and for this y cap let us substitute it by y minus e. So this is y cap transpose y minus, in place of y cap let us substitute it by its value, therefore y cap transpose y minus, and if we apply this property, AB transpose is equal to B transpose A transpose, so this is y cap y minus, and here x and e, they are orthogonal, so this is equal to 0, so we are left with only this term. Now again, from this expression, actually y cap transpose y cap, now let us substitute the value of y cap on the left side, and in place of y cap let us write it as xb. This is equal to y transpose y cap, and is the error and x, they are orthogonal, again this is equal to 0, so this is again equal to y transpose y cap. And if we have derived the sum of the square due to regression, this is equal to, so in place of y cap transpose y cap, we can substitute either of these values, and in fact this was equal to beta transpose x transpose m0 x beta, and in place of this y cap transpose y cap, we can substitute either this value or even this value. This can be written as y cap transpose m0 y cap, and following this result we can write it as y cap transpose m0 simply y, or we can write it as y transpose m0 y cap. Now let us construct the analysis of variance table. So finally, in this video, we have identified the total variation in y, and we have distributed it into two parts. The variation explained, the variation of dependent variable explained by the independent variable, that is the regression. Then after the unexplained variation, and we have identified their degrees of freedom as well, and we have created the analysis of variance table. This is also called as the ANOVA table for the linear regression equation, and we have expanded this term as well. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Saturday.